Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. We want to present our final project report. Okay, let's begin. Next, next. First of all, we want to introduce our group member. First, me, Muhammad Ridho Sunation. Next,
And the next one is me, Gustav Beka Sayudha.
And I'm Muhammad Hanif.
okay, the first material will be presented by me. Next. Background. Dataset. The dataset used in this project focus on arithmetic and consists of 452 rows of data. Each row represented a specified case, while the dataset contains total of 280 attributes or features associated with each case. Pre-processing. This is a step-by-step process for analyzing the quality of given data. Method. In this project, we employ two algorithms, namely key nearest neighbors, KNN, and native Bayes. Next. Naive Bayes. Naive Bayes is classification algorithm that is based on Bayes probability theorem. It is often used for tasks where the objects it used assign a given input to one of several predicted categories or classes. The algorithm uses Bayes' theorem, which calculates the probability that particular input belongs to each class, and assign the input the class with the highest probability mathematical. Bayes' theorem is expressed as follows. This is the Bayes algorithm that we have adopted. Basically, we are trying to find the probability of even A if even B is true. Even B is also referred to as evidence. PA is a probability of A, probability probability, etc. The probability of uneven before evidence occurs. The proof is the attribute value of the unknown instance. P or B is the procedure probability of B, that is the probability that it will occur after the evidence is shown. Next, KNN. KNN, which standard of key nearest neighbors, is a popular supervised machine learning algorithm used for classification and probability tasks. KNN works on the principle that any data point class to each other will be in the same class. In other words, KNN classifies new data points based on the similarity. In our class, we use the equality, which is it's for example. Next, for demo will be presented by Gustav and Hanif. Please, Gustav.
Okay, so for the first one, we have naive Bayes here, and it will be presented by Muhammad Hanif.
Okay, thank you for the time. So I will explain uh, how the naive Bayes algorithm works in our dataset. So first here, we need to import our library, which is we are using pandas and math. Then we create our dataset using the panda library for easy data manipulation, analysis, and various mathematical functions. Then, and then here we need to pre-processing the data, which is we will convert the value uh, of the class column to 0 and 1, which indicates the healthy and the sick respectively. And then the next is this, we have the output of our data set. Next is the arithmetic info of our chosen data set. Then we have and then we drop the unnecessary column from our data set. In this case, we will drop the uh, in the column from index 9 to 279, and also the index from 1 to 4 column. And then we also um, add column ID to the dataset data frame. Then we have here is the our dataset in our current variable, which is arrhythmia. Next is for the normalization min max. This is the function uh, will compute the min max normalization on specified columns. In this case, we will normalization these five column, which is curious duration, peer interval, Qt interval, T interval, and P interval. And then we have the output of our normalization data here. And then next for the standardization, uh, it means this function will perform standardization, will also known as z-score normalization on specified columns. Same as before, we will use the column of curious duration, peer interval, and so on. And then here we have the result of standardization of our data frame. And then next to the split truth, uh, this function will separate subsets based on unique values on specified column. In this case, we will target column is the class column. Then we separate it into yes and no data. And here we have the yes data result. And next is the no data result. And then the next one is we will find the mean of our data. It will collect the mean value of specified columns into data frames, which is the yes data and no data, which uh, in the previous section. Will also print and return the yes mean and no mean variable. I mean dictionary. It will contain the dictionary of specified columns in the respective data frames. In our case, in is the arithmetic data frame. Yeah. This is the result of the bin result of the five column that we mentioned before. The the and let's continue to the find the standard deviation of data of the two data we used before, which is yes data and no data. And it will also return the standard deviation of the yes data and no data to the new variable, which is yes standard deviation and no standard deviation of the five column we process. And then this is the result of the standard deviation of the previous function. We'll continue to the calculation probability. It will calculate the probability density value for a given input, mean, and standard deviation, and the x. Uh, we'll continue to the confusion matrix. This will compute and prints various performance metrics based on the provided result data. This result data is a list of dictionaries containing prediction result and ground truth values. And we'll continue to the prediction the to prediction function. This function uh, will perform prediction based on mean and standard deviation values for two classes, yes and no, which we already have them in the variable we have made. And then we will return result as the many parameter. And then we go to the result section. This is will be performing predictions on the arrhythmia data using the do prediction function and printing the prediction results and the confusion matrix. Note that the code assumes that the necessary variables, which is yes min and no min, will be correctly defined and available in the current scope. And here we have the result of our knife Bayes algorithm, which have the 78% accuracy. I think that's all. I will give to Gustav to explain the KNN algorithm. Thank you.
Okay, thank you, Hanif, for the explanation of knife Bayes. Now I will explain for the KNN algorithm. In the first part, we of course import the library that we are going to use. We use pandas, numpy, and math to perform various mathematical equation and also to read the dataset that we have. Firstly, we obviously read the datasets, and then we print the number of rows and columns. We have same number of rows and columns, and then we change the class column. It is initially has one value between 1 until 16, with each value corresponding to a specific meaning. For example, 1 has a meaning of a normal, 2 has a meaning of ischemic changes, and so on and so on. And we change those integer value into string value that has corresponding to each description of the number. And here we can see the results of that change. And this is also the tail of the data frame. And then we also print out the class unique to make sure that we change everything and it is unique. And this is the info of the data frame. And the same with knife Bayes, we think that only these five columns is crucial to determining the arrhythmia problem. So we just to drop the column between 0 until 4. That is the index of 0 until 4. And then we also drop column with the index 9 until 279. And that leaves us with only these 5 columns and also the class itself. And then this is the describe that shows the details of the data frame. And we also drop null, and this function is used to drop any null function. And as we can see here, it stays 452 rows. That means there are no null functions inside our columns here. Between these 6 columns, there are no null value. And we go to the next one, which is we use the sample function and reset index function. Now, the sample function, we choose to choose one of the rows in our data frame, and then we change it to 420 because it's easier when we are doing in the folding phase. So it will be divided nice and evenly. And then after we take the sample, we reset the index itself. And this is the results of the DF sampling, data frame sampling. And then we move on to the folding part. Now we are folding our data frame into 7 parts, and each part has 60 different rows. So for example, fold 1 has rows from 0 until 60. Fold 2 have 60 until 120, and so on and so on and so on, until we have 7 folds. And this is the result of the folds itself. And then we also use normalization here. It's the same as knife Bayes, and we implement it by using the normalization formula. But we're going to use this for function later. For the next one, we need to create another data frame that doesn't have the class. So we use X variable for the same data frame, but minus the class column. And we also save the class itself into a new variable, which is Y. And here we can see the result of X. It has 5 columns and the value in each row. After that, we use the normalization function to normalize the X data frame. And here we can see the result of the normalization. It's 0 point something something something. And this is the description of each data frame itself. It has a count of 120, a mean of so on, standardization of so on, and so on. Now we also use function Euclidean here. It is used in our KNN training. And this is just to prove that our Euclidean formula works. And it has a results of 0.163 and so on. Now in our function, in the next function, we have KNN function. This is for the KNN training. We have 4 parameters: X train, Y train, X test, and K. K is for the integer value of that we're going to use in the nearest neighbor comparison. X train is our training data of X. Y train is our training data of Y. And if you remember that X is the data frame without the class column, and Y is the data frame that only has the class column. And X test is the test data frame of X. Now in this function, we just basically do a KNN comparison by using the Euclidean formula function that we have above. And then after we use the Euclidean formula, we add the data that we have and sort it by values of the distance. So it compares the distance between each point of the data to determine whether it has the nearest neighbor or not. And it returns the prediction of the function after we predict the nearest neighbor. And then we have another function here, ACC, or we check the accuracy of the prediction to the true value. And this is the function, as you can see here. And we also use the evaluate function. And this is to evaluate the model that is using the folding data that we have from the above. And we can see it normalize X train and normalize X test. And then it returns the accurate, or rather the accuracy between Y prediction and Y test. It compares between the prediction and the test results. And lastly, we have the results of the KNN algorithm. We choose to have K value of 7. And we have the 7 folds as we previously mentioned. And then it do a iteration to evaluate each folds that we have using our K, and the result itself we print out using K equals 7. It has an average accuracy of 0.450007 or 45% accuracy. I think that is all for the demonstration of our code of naive Bayes and KNN. The conclusion will be explained by Ridho.
Okay, the conclusion. First, the naive-Bayes algorithm can provide a higher accuracy than the KNN algorithm. Second, the naive-Bayes algorithm is more effective than KNN algorithm. The KNN algorithm uses random samples, it causes inconsistent results. And then the last one, what the algorithm that classification is efficient and can provide the best prediction. Next. Suggestion: to interest further studies, it's recommended to explore specialist reference on the application of two algorithms in the healthy domains, particular for any arrhythmia classification, to understand their strength, weakness, assumption, and how to appropriate prepare data for improvement management of arrhythmias. Next. Thank you. I think that's all. We are from group 7. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you.